Let me come back to example number 6. As you talked about it, it is first order nonlinear, and also like it is not separable, which means there's no way to solve the problem by the separable. But as I mentioned about it, we hope, inshallah, your left-hand side is the partial differentiation form with respect to x, okay? So to check this one, we have to do the checking my is equal to nx from the theorem number 5, right? So here we go. Step 1. So which part is m? 2x plus y squared is your m, and 2xy in front of y prime is your n. That's it, right? Then let's do it. What is my? Just we're going to take the derivative with respect to y, okay? Then x is constant, so which means 2x prime is equal to 0. And y squared prime is 2y, okay? And what about nx? With respect to x, which means other things are all considered as the like constant, right? And then 2xy prime is 2y, because 2xy is 2yx. Then 2y is the coefficient of x. So 2yx prime is 2y. Is it okay? Wow. They are equal to each other? Check. Therefore, I can say that is the exact differential equation, okay? And as I said, there are two ways. Don't forget this one. So your m, we assume your m is equal to d psi over dx, right? And your n is equal to d psi dy, okay? You can start either way. If you'd like to start from m, we're going to take the integral with respect to x. And if you'd like to start from n, we're going to take the integral with respect to y. So like which one? Either way doesn't matter, okay? You're going to have like same answer, okay? So for the practice, let me start from, this time, let me start from n. Is that okay? But you can try to like practice with the other one, is okay? N, okay? So since your n is d psi over dy, we're going to take the integral with respect to y, okay? So integral n dy is equal to my target function. So integral, what was my n? There we go, 2xy. 2xy dy is my target function. And integral 2xy, but keep that in mind. Don't confuse about it. This is not the product form, but because we have to consider 2x as your coefficient, okay? So it is 2x times 1/2 y squared and constant, right? But keep that in mind, this constant is not just constant. It will be constant and function. That's why we have to write as f of x for here, okay? That is equal to psi x, y. We're almost there, right? Let me simplify. Therefore, I can say psi xy is equal to xy squared plus f of x. But like still we do not know about like f of x. How can you find it? That is the way, like that is the part that I have to use m now. Think about it. Your m is the derivative of psi with respect to x, right? So that when I take the like derivative with respect to x, which is equal to y squared plus f prime x must be equal to, what is it? M, which is, what was it? 2x plus y squared. 2x plus y squared. Now look at your left-hand side, right-hand side. Oh, we have y squared on both sides, right? But on the right-hand side, which m, in the m, there is 2x. Can you guess about that? That is exactly your f prime x, right? So therefore, I can say f prime x is equal to 2x, right? Then anti-derivative. And now there's constancy. This is like a real constancy, right? Then once you find f, then keep that in mind. Finding psi, this was solution, right? We're going to place back here and update. Therefore, my psi x comma y is equal to xy squared plus x squared plus c. But for here, we are not going to write c yet because it will be added at the end, okay? So what I want to say, so let me erase this one at this time. It might better to erase here as well, okay? And then, therefore, my solution is xy squared plus x squared is equal to c. This is the final form. Okay? Keep that in mind. It must be psi is equal to c form. That is my final form. That's why your final answer must be like, your psi function that you find must be equal to c. Okay.